Hello, you guys. For the last section of Module 15, we're going to be talking about circles on the coordinate plane. Now, remember, the coordinate plane is exactly what you see below right here. It's where we graph. Okay, and so how do you graph a circle? Well, remember the things that we know about a circle. Circle is named by its center, and any radius is the same. So that means any distance from the center to the side is the same. And so, for example, here, from the center, from the center to the side. Let me do this way. Okay, so from the center to the side is the same distance all the way around. And if you notice, that distance is 3. And so we know that the center of this circle is 7, 5 is the point, 7 is the x value, 5 is the y value. And we know that the radius equals 3. Well, the reason that I point that out is because the equation of a line is determined by finding both of those two pieces of information, the center coordinates, an x and a y, and the radius. All right, so let's start with what is the equation of the circle? Well, HK represents the center. Remember, H is the x value, K is the y value of that center. And then R is the radius, the length of the radius, okay? And we can easily use this right here to say this radius is 3 units long. And it's going to be the same all the way around. All right, so how do we write the equation? Well, we put it in this form, x minus the x value of the center, and we square that, plus y minus the y value of the center, and we square that. Now let's talk for a second, because it's really important that you understand, what does this x and this y represent? They stay in the equation. If you look right here, another type of problem we're going to do in this section is we're going to be given the equation, which is what you see right here. We have to find the center and we have to find the radius. So what does that x and that y represent? It represents every one of these points on the circle. So all the way around, those are any of those points. And so for that reason, we had to use H and K to represent the coordinates of the center. All right, so then let's go to this problem here. Let's write the equation of the circle pictured on this coordinate plane. Okay, well, we know it's x minus the x value. So this time the x value is 7, and we square that, plus y minus the y value, which is 5, and the radius squared. So we have to square 3, which gives us 9. Now, if you can imagine for a second, look at this equation. Do you see that if we take the square root, if we undo squaring, we take the square root of 9, isn't that 3? That's what our radius is. If we take the opposite of this value, 7, that's the x coordinate of our center. The opposite of this is 5. That's the y coordinate of our center. All right, so then let's do the opposite type of problem. Find the center and radius when given the equation. Okay, again, let's review. The equation is always in this form. This is the standard equation of a circle. X minus the x value of the center. Okay, well then what is the center? X minus, well, this is a plus. So we always do the opposite. So the x value of the center is -3. Y value is 4. Okay, and what's the radius? With this r squared. Now, how do we know it's r squared? Because that's the standard form of the equation of a circle. So the square root of 36 tells us our radius is 6. Now, here's what's so cool about that. Think about when we learned about the equations of lines way back in algebra. And you learned if you got it in y equals mx plus b form, you could easily graph it. The same is true for the equation of a circle. If you have it in standard form, which is what you see here, then you can easily graph it, because once we know the center and we know the radius, can't I very easily say, okay, the center is at -3, 6. 6, there's the center, radius is 6. So I go over 6 units in each direction. 1, 2, 3, 4, 5, 6. Okay, there's one side of the circle, or one bound radii drawn. I go here, 1, 2, 3, here's the other side. go over 6 this way, 1, 2, 3, 4, 5, 6, and I go up 6, 1, 2, 3, 4, 6. Okay. And now I connect those 4 points. Now I'm sorry that I'm not a very good drawer with this instrument, but now I have a circle, simply using the equation given. All right, now that seems super easy compared to what we're about to do. We're about to review a segment of algebra that you learned, but we didn't do a ton of problems with this, okay? And what we learned here, let me get the page switched over here. Something called completing the square. All right, so trying to get my page. Okay, next page. Here we go. All right, so completing the square to find the radius, and this is center right here under my picture. All right, notice here is, okay, here's the standard form of a circle. But look at this mess. That is not in standard form. What do we do to get it in standard form? All right, completing the square is a very technical process, but it's the same process over and over and over again, okay? All right, so the first thing, we're already set up for success because all of our constants are on the right side of the equation. So we want to move all of our constants over. All right, now once we do that, we put this in x squared minus 4x here, and we're going to leave a space. Okay, and then we have y squared plus 12y. Okay, and then this equals negative 24. Okay, now we take these in 2 parts. So we're going to do the same process twice, one for the x values, one for the y values. Okay, the way that you complete the square, we say x squared minus 4x. Now we take half of negative 4. Yes, we include that negative. Half of negative 4 is negative 2. And we're going to square that. Okay, so this is what we just put on this side of the equation. So guess what? It's an equation. What we do to one side, we have to do to the other. That's negative 2 squared. Does everyone agree with me? We're adding 4. If we added 4 to this side, we're going to add 4 to this side. Now I know we're all saying, oh my goodness, this is so confusing. Okay. Please just stick with me. You're going to want to reference this video over and over and over again in order to be able to understand this process well. It takes some practice. All right. As I said to you, we're going to do the same thing on the other side. The only reason I'm putting these in parentheses is to separate the x's and the y's so that you understand. Y squared plus 12y. Now remember what we did. We took half of negative 4. Okay, we're going to do the same thing here. Half of 12 is 6. And we're going to square that. And so 6 squared, if we do 6 squared on this side, we're going to do 6 squared on this side, which is 36. Okay, now let's look at what we have. What we have created, is a perfect square trinomial. Now that's a lot of fancy words. All that means is if you were to factor it every single time, it's going to factor to a perfect square. Well, why is that important? Because look, our standard equation of a circle is always factored to a perfect square. Okay, and so right here, what we know is this is always going to factor to x minus 2 squared. See that? The reason I highlighted that is because that's what number will always go there. Always, always, always. But then look right here. It's going to be y plus 6 squared. Negative 24 plus 4 is 20. 20 plus 36. I'm sorry. Negative 24 plus 4 is negative 20. Negative 20 plus 36 is 16. Okay. Now you should recognize that this is the standard equation of a circle. Let's review before we go on. What did we do? Okay, we started with this mess right up here. We got all our constants on the right side of the equation. And then we did the same process called completing the square twice. We brought the x squared down. We brought the -4 down. We took half of this coefficient. Remember, coefficient is the number in front. Half of -4 is -2, and we will square it. What we do to this side, we have to add over here to this side. -2 squared is 4. So if we did +4 on this side, we have to do +4 on the right side. We have to keep the equations balanced. Okay, next, we brought down the y squared plus y squared. We brought down the plus 12y. Half of 12 is 6. 6 squared is 36, and that's where we got that over here. We added 6 squared here. We bring it over here as well. Okay, now the reason that I kept this as -2 squared is for you to see that's where we get this number right here. So it automatically factors. Okay, so what that results in, if we follow those exact steps every time, is we get to the standard equation of a circle. And the reason we want the standard equation of the circle is because we want to find what is the center and what is the radius. Hopefully already in your head, whether you understood completing the square or not, once it gets to the standard form of an equation right here, once it is in this form, we should be able to determine center and radius very quickly. The x value is +2. Remember, it's always the opposite. Y value is -6. This is radius squared. So the square root of 16 is 4. And now we would be able to graph this circle. How do you graph a circle? You find the center. You plot the radius, going right, up, down, and left. And now you connect your points for a somewhat okay circle. Okay? All right. Again, please hear me. This video you're going to have to watch a few times and then practice completing the square. Okay, this is a great reference for you. All right, lucky for us, the next part, very last question in this video, is not nearly as difficult, so you'll be happy about that. Let's get to that. Okay, so here we want to say, we're asked the question, does this point, square root of 5, to lie on the circle that is centered at the origin? So that means the center is 0, 0, and it contains this point 0, -3. Okay, so notice what was done here for you. Here's the center. Here is the point 0, -3. What does that tell you the radius is? Exactly, it's 3. So now we know the radius is 3, but Miss Williams, that's -3. The length cannot be negative, okay? And so here we have a radius of 3. That means we could plot this point up here. We could go this way, and we could go this way. They draw a much better circle than I do, and so now we have the circle. All right, so does the point, so this tells you what we did first. We graphed the circle, okay? So that's what we just described. Plot the point at the origin and this point, and then find other 3 points. Because you know the radius is 3, we have our circle. All right, back to the question. Does this lie on the circle? Well, remember we determined our radius is 3. What is the equation? All right, let's write it in standard form first. Equation of a circle. X minus h squared plus y minus k squared equals radius squared. Okay, h is what? It's 0. So this is x minus 0 squared plus y minus 0 squared, radius squared. So we have to square 3, we get 9. We can write this as x squared plus y squared equals 9. All right, now we have the equation. All right, just a side note. Whenever you see x squared plus y squared, you always know the radius, center is at 0, 0. Back to the original question. Always make sure we answer the question that's asked. Does this point lie on the circle? Remember what I told you? This x and this y represents just points. points on the circle. So if this point, negative or square root of 5, 2, lies on the circle, it would satisfy this equation. So we simply plug it in. All right, so x is square root of 5 squared plus y, so that's 2 squared. Does that equal 9? Well, square root of 5 squared is 5 because those are inverse operations of one another. 2 squared is 4. Oh, I messed that up right there. Does that equal 9? Yes. So then yes, the point square root of 5, 4 does lie on the circle. All right, this concludes our lesson and instruction on the equation of a circle, finding center, finding radius, that really messy technical process of completing the square, but I know you can do it. It's simply 3 steps. And then is the point on the line? And once you understand these 3 slides that I've just shown you, it should give you a thorough understanding of that equation of a circle. Again, to review that, it's simply this right here. X minus the x value of circle plus y minus the y value of the center. Sorry, that's the x value of the center, y value of the center equals the radius squared. And then remembering this x and y just represents some point on the circle. Now you know what the values represent in the equation, and so we can use that equation to find any of those missing values as we come across different problem-solving opportunities. All right, this wraps up Module 15. I can't wait to see you guys hopefully soon. If you have any questions, please email me. There is a Canvas discussion board created for you to review Module 15 homework. Please put your problems in there, ask me questions. I'll be happy to work out solutions for you, show you those solutions, and help you in any way I can in this format. Miss you guys. Happy Easter. I hope you had a great Easter, and I look forward to talking with you soon.